Okay, so now we are going to focus on the linear convolution uh, problem using the graphical method. So prior to explaining this program, I have to draw a diagram like this. What I do initially is I draw this black lines, and this red line, since I am not having another option, I have highlighted it as red. What would be enough is to draw broken lines while you're writing your exams, and I'll just demo a few examples, maybe one or two samples, and then you can do it on your own, but all you need to get is the concept. So let me begin with this particular problem. So since this is a graphical method, you should be aware of how to draw the particular concept using the graphical method. So what we are going to do here is basically represent the signals. So let these red lines designate the positions, like this is 0, this is position 1, this is position 2, this is position 3, and this is position 4. And this be -1, -2, -3, and -4. I may not need all of these positions, but then it's for you to understand. So each of these line designates a position, and I'm drawing my signal x of k in this direction over here. So for that particular option, x of k is 1, 2, 3, 4, which means x of 0 is corresponding to 1. So I have a sample that I draw here, and it will be at position, or it will be having the amplitude equal to 1. I'm having the next sample at this position 1, so it will be having the amplitude 2. I'll be having the next sample at this position 2. I'll be having the amplitude 3, and I'm having the next position sample over here, which will be having the amplitude 4. So that represents x of k, and we are done with the drawing part of x of k. So x of k is drawn, and it should be clear to you. Now we have to draw h of k, and h of k, I'm using this next graph over here, and as written over there, h of k is 1, 5, and 7. So at position h of 0, it will be 1. At position 5, at position 1, it will be equal to 5, and at position 2, it will be equal to 7. So one needs to get a concept. I should have put in a big space between these two, but then I hope this concept is clear. Don't mind the amplitude, exact amplitude of this particular signal. All I'm trying to do is represent it using samples. So I have drawn x of k over here also. So this is the desired output that we are supposed to get. So when we look at the formula, we get y of 0. We are supposed to get y of 0. So when we substitute it in the particular formula, n minus 1 x of k into h of n minus k. Now when n becomes 0, as for the 0 over here, it becomes x of k into h of minus k, which means to find out y of 0, you have to operate x of k with h of minus k. Now let me tell you something about this. Now x of k is basically the signal that is available over here, and you have no doubt about it, it's the same. But you have to operate it with h of minus k. But what we have here is h of k. Now we have to create h of minus k. So when we have to create h of minus k, what did I tell you? H of minus k is a folded version of h of k, which means it is an exact mirror reflection. Now it would be centered at 0, so it will remain as 1 over here. The 5 which existed here will come as 5 over here, and this will be equal to 7. This refers to the folding of the signal. Now as mentioned here, to get y of 0, you have to operate x of k with h of minus k. So when we compute it here, y of 0, we do element by element addition. So this 7 has got no corresponding element here, so it will be 0. 5, no element over here, it will be 0. And 1 over here and 1 over here, so it will be 1.1. And similarly, you have no element to multiply 2 or 3 or 4 with over here. So your y of 0 is essentially 1, which is the output that you have here. Let's go for y of 2. Now here comes a tricky part. Now you have to get a logic about how this shifting happens. So let me point it out this way. I have a kind of analogy to remember or understand this. So when we talk about x of n as a normal signal, if we have two different versions, x of a shifted signal can be represented as x of n minus 1 or x of n plus 1. This is for understanding the logic. X of n, if it is shifted, it could result in two signals, x of n minus 1 or x of n plus 1. Now, when we talk about x, we spoke about that there is a shift in the signal, but we don't know in which direction it has been shifted. So, in order to understand that, I think we can follow an analogy like this. If it is n minus 1 over here, we equate it to 0. So, n becomes 1. Which means it has shifted to right. Now here n plus 1, if we equate it to 0, n becomes equal to minus 1. So which means you can treat it as x. So ultimately my point is, for x of n minus 1 can be treated as a shift to right, and x of n plus 1 can be treated as a shift to left. This is a point that I want to convey. Now when I speak about the folded version, the concept will be exact opposite. So it will mean a shift to left and it will mean a shift to right. Or in summary, if I am supposed to give it as a table, probably I can give it as follows. So maybe you can follow this as your analogy. So if it is x of n, the normal signal, and if it is folded signal x of minus n, a shift of minus k please note that there's a change in the variable over here, so that has to be correctly understood. Shift of minus k will indicate a shift to right. A shift of plus k indicates a shift to left. Now when it comes to a folded signal, x of minus n minus k will indicate a shift to right, left, and x of minus n plus k will indicate a shift to right. This can be followed over here when we apply this particular or try to solve this particular problem. So now to find out y of 1, let us go for y of 1 right now for easier understanding. What we see here is it becomes summation k equal to 0 to n minus 1, and x of k is to be operated with h of 1 minus k. So when we eventually look over here, we can see that x of k has to be operated with h of 1 minus k, which is the shifted version of h of minus k. So when we look at it in that perspective, it is h of 1 minus k can be treated as equivalent to h of minus k plus 1. So as per the logic that we have built earlier, we know that a shift in plus direction will indicate a shift to right. So I'm using that particular logic. So h of minus k plus 1 will indicate a shift of, as per the logic here, the folded signal x of minus n. If it is having a shift of plus k, it will indicate a shift to right. So h of minus k has to be shifted to one place to the right. So when we look at it, this is h of minus k, and this will be what I'm trying to do here is h of minus k plus 1, and h of minus k plus 1 will be h of minus k shifted one place to the right, indicating this will become 1, this will become 5, and this will become 7. So which means y of 1, eventually when we multiply each of these components, the 7 has no counterpart to multiply with. The 5 over here, the 5 over here and the 1 over here, 5 has got its counterpart in the form of 5.1, and 1 can be multiplied with 2, and hence it becomes 7, and which is the answer that we have over here as a second term. Now let me take this a little bit forward, and we'll try to solve this problem for another one more term, that is y of 3. Let's try this problem for y of 3. So y of 3 means x of k will have to be operated with h of 3 minus k, which means it is h of minus k plus 3, and h of minus k plus 3 will be h of minus k shifted 3 places to the right. So this will be first step, this will be the second, and this will be the third. So this will be 1, this will be 5, and this will be 7. So that is 3 places to the right. So this is one shift to the right. Second would have resulted 1 coming here, and the third shift would result this signal coming here. So when we go for y of 3 over here, when we do element by element multiplication, we can see that it becomes 4.1 plus 3.5 plus 7.2, making it 4 plus 15 plus 14 equal to 33, which is the answer y of 3 we have over here. So we have obtained y of 0, y of 1, and we have obtained y of 3 using this particular concept. So this should be helpful in solving this particular problem, and I hope the concepts are clear. We have so far learned about linear convolution and the 3 methods of solution. The first was a tabular one, which should be the easiest way. Then we looked into the formula method, and then we looked into the graphical method. This has to be applied. Let me remind you that is in this video I have not solved for the entire question, but then this solution has to be found out for all the values using this particular concept. So I hope this video helps you in understanding the concept and helping you solve this particular problem.